Welcome to Chapter 6, which is linear regression. Now, the name is a little bit deceiving, linear regression. Linear doesn't mean that the function that you are going to be fitting your data with is actually linear. It just means that the coefficients out in front of your variables are all linear. Regression is a process of trying to get your theoretical curve or line to go through the points with the least amount of deviation. And we're going to talk more about that in the future. But for now, let's just say linear regression is trying to get a function that fits your data. And this is a very common task in engineering and science where you have some experimental data and you're trying to create a theoretical model. All right, we're getting into this first one, regression functions. It's on page 257 to 259. So the first part is you're just going to type in this, this set of data right over here on the left. Easy enough. All right, you're then going to name this block right here times, and this one here actual temperatures. Okay, actual temps. Okay, so by naming those, we can use some functions. So down in here, this is just equal slope. So I'm just going to quickly do that for you, show you that it's not magic. Equals slope. Okay, open the parentheses. Now when I drag and get those, notice it picks up times. So the first thing in the slope is that you want your time or horizontal variable. And then I do comma. I pick up my y values, which notice it pops up as actual temperatures. All right, so those are my two sets of data, and I'm going to try to find the slope, and I get something wrong. Why? What did I do wrong? Well, this is what I'm going to do. I better do this. Okay, let's do equal fx. Let's put in slope. We'll get go. Okay, put OK. All right, so I'm supposed to put the y's first and the x's second. Okay, so I needed to put this here first and that there, and I put OK, and now I get the 278. And you need to include units. It's the y-axis, which is Kelvin, over the x-axis, which is minutes. The intercept, that's the value of the function when you hit your horizontal value of 0. So you can see that's about 296. That's in Kelvin. That also has a function, and you have to put the y value first, the x is second. The r squared, that's a function known as RSQ, and you can get those. Now, once you compute these slopes and intercepts, then you can compute your predicted values. Okay, so all I did here was just said it's equal to the intercept plus my slope times my x value right here. All right, and then I just drag that down. So the only relative address is the time, the A6 or A5 or A4. All right, then just plotted out those two things. Keep in mind, just from chapter 3, the predicted temperatures are just a line with no markers. I'm just going to right click on that. There's format data series. It comes up over here. I find out, the fill in line. So if you want no marker, remember you just hit marker. I have none. For the line, I put a solid line in here. Likewise, if I was messing around with the other ones, which are the actual temperatures, in that case, I had no line, you see here, and I chose an automatic built-in marker. Okay, so just to remind you, and then that's a legend. So hopefully from chapter 3 you remember all this stuff, how to use the design, the quick layout, the legend, you can add things. So hopefully you're pretty good at that stuff by now. But that's a pretty self-explanatory spreadsheet. Good luck with it. Just make sure you name your times and your actual temperatures to make things more readable. Let's go over to trend lines. All right, this looks like a lot of work, but actually it's not that much. So you're going to type in this data on the left, and then you're going to make 3 graphs. Well, actually, all you ever really need to do is make 1 graph on this one, and then you can copy the others and just change the trend line. So let me just quickly go through that process. So first thing I'm going to do is, I make this first data one, and I added a trend line, which we've talked about before. But let's say you forgot how to do it. Now, once you get one graph, like you get this linear trend line, to get these other ones, all I did was take this first one, do a Control C, which means I copied it, and then just click over here, and I'll do a Control V, and I'll get an exact copy of that. All right. Now all you got to do is go on to this trend line and do right click, format the trend line. If you want to change it to a polynomial, there you go. That's all you have to do. All right, everything else is going to change. Some things I just want to talk about, like for instance, putting a border and some white fill on the trend line equation. All right, to do that, I'm going to right click, format trend line label. Okay, so that's going to come up over here. Label options, oh my gosh. Fill in line is what I do. So I would do a solid fill. I would fill with white. You can fill with other colors, but you don't want to fill with black. Why don't you want to fill with black? Because I'm going to show you. That's what happens when you fill with black. All right, so you don't want to fill with black. So I'm just going to fill with white so it overlays the grids, and then I'm going to do a solid line on the border, and you get a nice thing. And you can do the same thing for the format legend. Okay, but once you get one of the graphs done here, you just copy twice over, just change the equations, change the titles. You're good to go. Once again, it's a matter of working smarter, not harder. Regression analysis is our third one. You basically use the same data you used on trend lines over again. So if you're smart, you'll just copy and paste instead of typing it over again. Now this time, we're going to use the regression function that is in the data analysis set. And with that, you get a lot more data and statistics coming out about your fit. All right, so if you're a statistician who has to make some statements about whether your function is fitting properly with this data, you'd want some of these other things. At some point in your college career, you should take a statistics course. It's something that's going to be very valuable to your engineering career, and that'll help you understand what all this stuff is. But for now, I'm just going to show you how to do it. All right, so this is the finished product. You have your data. You're going to get a graph, a scatter graph. You're going to get some statistics. The most important things for us is it's going to give us our intercept and our slope, which is going to be your B1. All right, so the formula or the function that we're fitting your predicted temperature is it's going to be B0 plus B1 times time. So the B1 is your slope and your B0 is your intercept. And I can see I've misspelled this word predicted, so there you go. I've fixed it after all these years. Since 2008 it was misspelled. All right, let me show you how I did. I'm going to go to a sheet that doesn't have it on there. All right, so here's the deal. All right, you're going to go to data, and you got to have data analysis in here. If you don't have data analysis, remember we've used data analysis I think before, but you probably forgot. So if you don't have data analysis, you have to add it in. So I'm just going to go back. I do File, and then I'm going to go to Options, and then I'm going to go to Add-ins. Okay. Now my analysis tool pack has already been added, but if yours has not been, you'd click on it, you'd hit go, you'd click then Analysis Tool Pack. I guess we don't need the Euro currency tools. They certainly don't probably need those in Britain anymore with their exit from the Euro Union. Okay, but anyway, we have the Analysis Tool Pack. All right, now we're ready to roll. So once you have that in the Data tab, Data Analysis, you're going to be good to go. All right, so we want to create a regression on this. So of all these things you choose, it's coming up to regression because that's the most recent thing I've used. There's random number generator. That's another thing we've used. So let's put OK on regression. And it's already filled my boxes in. Okay, so let me unfill it because, all right, let's get all this stuff off. Okay, so yours is going to come up looking like this. Okay, so input Y range. All right, what I would do is I would include the title of the column, temperature, and on my X range, include the time in minutes. So that way they're going to come up on your graphs automatically. Now when you do that, if you've included the labels at the top of a column, you need to tell Excel that you've done that, and that's what the label tab does here. Okay, down here, the way it is right now, it's going to create a graph on a new worksheet. If you want it to lay in right on this worksheet, then you have to click up on this output range, and then you have to click in this cell. So let's say we want the output range to start on A16. Now some other things we want a residual plot, and we want, it says line fit plot. That's actually going to be a scatter plot. So I'm going to put OK, and there is all the magic. Okay, so first thing you do is going to bring this plot up here, and then you have a residual plot. Well, you've got two residual plots. Why do we have two? Are they the same thing? They're the same darn thing. We got two of them. Okay. It's kind of like a vending machine. You put your money in, you got two of them. All right, this one, we want to make these graphs look nice. In fact, we don't have to do anything on this one. Just resize it, move it over. So if you did have to print it out, it looked nice. So nothing you have to do on that one. Residuals are the difference between the predicted value and the actual value. All right. So if they're bigger, if they're on the top side, probably the data is bigger than the predicted, and if they're below, it means the data was less than the predicted. Now this graph, I want you to pretty up a little bit. So if you look at your homework sheet, you can see what I want that to look like. So you're going to have to change some of these markers. You're going to have to put a new title in. I'm not going to go through all that just to say this is what I want it to look like. I want you to put the function in. Now where did the 296 and 2.78 come from? Those right down here are your intercept B0 and your slope B1. Okay. So when you do that regression analysis and come down here, I want you to highlight these cells because those are, I mean, there's so many other numbers. We just want to show everybody what that is. So I'm going to just use a yellow fill in there. I'm going to put borders. I'll just put all borders in there. And you can say, okay, that intercept is going to be your B0 value. If you want to make that a subscript, remember you go to font, bring this down, hit subscript, put OK, and now you're starting to look like a genius. Over here on time, we're going to make that B1, and we're going to subscript the 1. I do the same thing, subscript, bam. All right, so make sure that you do this. Make sure that you make your graph look nice, like this one right here. All right, so if it doesn't look like your homework sheet on page 3, your instructor is going to wallop you. One last thing is we have to make sure that our graph is a scatter plot, not a line graph. In this case, it actually doesn't matter because we have equally spaced data. And if you have equally spaced data, a line graph's going to look just like a scatter plot. But if you're not sure, in fact, you should always just check here this way. All right. So I'm going to right click on this graph, and there's a thing called change chart type. So let's left click on that. Now right now I see that what we got was an XY scatter. All right. So I'm good to go there. Let's go into my regression analysis too. This is the one that I just got automatically off of the Excel regression function. I'm going to change chart type. That came up as an XY scatter. So even though it says it's a line plot, I wish they would say that that's actually a scatter plot. Okay, so that's a scatter plot. Remember, we do not want to use line plots it's okay to use the line plot down here. Let's just see what they put down here. Change chart type. Oh, they use the scatter there as well. Alrighty, so they're mislabeling things, calling things line plots instead of that. All right, let's go to a polynomial regression. All right, in this one, we're going to have three coefficients, a B0, B1, and a B2. So I'll just make this a little bigger so we can see that. Now I'm going to do some typing. Remember, I want all that highlighted. Okay, so we have a little bit more complicated function. We've got a constant term, we have a linear term in time, and we have a squared term in time. So the 297 is B0, the 1.7 is B1, and then 0.11 is B2. All right, if you've got three terms instead of just two, what we have to do is we have our original data right here, and then we're going to just add another column here, and we're going to just use a formula equal B4 and copy that down. So we're going to have not only the temperature and time, but we're going to have time squared as well. So let me just show you all you have to do on this one. I'm just going to go to polynomial regression. This is one where all the stuff has not been put in. So let's just go over to data, and we're going to do a regression analysis with coefficients for time and time squared. So go to data analysis, regression, do OK. The input Y range right here, that's going to be temperature. Okay. The X range, now that's going to be these two columns. Okay. So not only the B column, but also the C column. We put that there's labels. We want our output to go to A16. Residual plots, line fit plots, and it looks like these are actual scatter plots. So I put OK, and look at, I got all this stuff. Look at all these graphs. All right. So what we want here is well, what do we want here? Let's take a look. I've got some residuals. I've got one for time squared, and we're just going to do the residual plot for time. Okay, so we can get the time squared one out of there. All right, that's mission accomplished 1. Okay, and we are going to take this one, which is going to be our just time fit plot. And we're going to get rid of the time squared. I don't really know what that one represents. So bring the time, bring that over. All right. You're going to change your title. You're going to, put it as exactly as it appears on page 4. In other words, you're going to make it look just like this. So then when you're done, I want your predicted values coming in with just a red line, and then your temperatures, no line, just markers. Make sure that you highlight or fill these three cells with yellow. Put the B0, B1, B2 there. You got a time residual plot. So there you go. That's good. All right, we're going to do a calibration. Now, a lot of times there's a certain amount of confusion here, so let me try to allay the confusion. First of all, you're going to just type in this data right there. Now, how are we going to get this predicted stuff? All right, well, if you look on page 281 of the text, this flow meter came with a calibration equation where there was an intercept and a slope. Okay, so these down here aren't calculations. Notice they're just numbers typed in from the book on page 281. So do not do a regression analysis with those functions equal slope. Now these are not formulas right here. These are just constants. All right. Now to get these predicted values, we then used these factory supplied calibrations. Okay. And that's what we created this first graph with. So the predicted, you can see what I've got one X value and I've got these two Y values coming in. All right. Now, down here on the new calibration, if you look, okay, just double click. Come on. Oh, come on. There we go. All right, on the second graph with the new calibration, notice we are not using the predicted over here. That's the factory prediction using factory slope and intercept. So we're using just the raw data, and this equation right here is a trend line. So you're just adding a linear trend line. So you just go on your data points and go on our data points. Well, since there's a trend line on here already, it doesn't come up. But if there wasn't one, if I went on there and I right-clicked, it would say, oh, there's it goes, add a trend line. You'd add a trend line, put the equation in there. So the factory slope of 0.0674 has drifted a bit. Now we have a better one, and we have a better intercept that fits the data. So there we go. Let's look at some of the problems that you have to do quickly. So on page 284, problem 6.1, that's functions. This is just, you're going to format your plot a little bit. Make sure that you use different line types, no markers, use different colors. Now, the reason why you want to use different line types in addition to using different colors is if you print this out on, let's say, a monochrome printer or just a grayscale printer, and they're all the same line type, you won't be able to differentiate. So it's good to use different line types. To do these equations, I've got two variables a and b here. So there you see. So just use named cells and things will go pretty quickly for you there. So nothing spectacular in this one. Okay, I'm going to just stop the video for a second, and I don't want to show you the answer on thermocouple, but I'm going to go to it. Oh, there are no surprises on thermocouple. What is this? That's an easy one. Oh my gosh. All you have to do is make a plot and add a trend line. All right, it's the conduction one that looks like it's going to be a little more complicated. So I'm going to stop the video here. All right, so now you're looking at this data. The most confusing thing is they gave you data on page 285. Actually, it's on 286. They give you the temperature that each of the thermocouples are on. So, you got thermocouples 1 through 5, but you have to convert that to actually positions on the rod. So the first thermocouple is on the left side. It's at position 0. Then the next one's at 0.05. Okay, so put all those in meters, and then you have your temperatures. Once you have those, then you're going to do a trend line plot. You're going to get your slope. Slope's going to be important somewhere. And you're going to do some calculations and eventually come up with your thermal conductivity. Okay, good luck with that one. Now I'm going to go to latent heat. Okay, in this case, you're going to do a regression analysis. In fact, what do we have? Actually, you're going to do a trend line. On this one, you're going to do you're going to create a couple new columns, inverse time and log of the pressure difference, or the pressure, vapor pressure. And then you're going to plot those out with, as you see up here. And then you're going to put a trend line on, and then you're going to have to find your delta H value. So have to get your slope of this, and then hopefully that's going to get things good for you. The orifice data. All right, you're going to use, this is the one you're going to use regression for. This is on page 289, 290. So you're going to have 3 columns here of data, V dot, delta P, and square root of delta P. Okay. So your prediction, you have a function that's given in the book, square root of delta P. It has to be a function of your V dot. So remember what you need to do there. You need to go to data, data analysis, regression. Okay, your Y value is not going to be V dot. That's your X value, and your square root of P is going to be your Y value. So keep that in mind. All right, good luck with these problems. I hope you are successful and get another 100%.